Welcome to the 26th lecture in the course of Industrial Engineering and Operations Research. We have discussed various topics on industrial engineering, including forecasting and quality. Now, we are going to discuss some topics which are very relevant to Industry 4.0, and among those, one topic is big data, and of course, the big data analytics, that means getting inference from the data, utilizing that data. So, if we first talk about the definition of the big data, what is big data? As you know, that data is that any piece of information you get, like you can say I can collect the age of some students, that is a type of data. So, a big data is a group of data from conventional and digital bases inside, outside the enterprise that characterizes a basis for continuing detection and analysis. So, that is one definition. Another definition is that big data is a quantity of data that is extremely relative and cannot be managed through the usual methods. So, this is somewhat relative, for in some cases you know that billions of data can be very small, and in some cases if you could collect about 2000 data, that may also become say big data. So, it is in a relative sense that normally what is the data size and what you have got is this one your size of the data, and it cannot be managed by normal methods. So, another definition is that which I generated from AI, that is big data refers to extremely large and complex data sets characterized by high volume, velocity and variety that exceeds the capability of traditional data processing tools, requiring advanced methods for storage, analysis and visualization to generate meaningful insights. So, this definition is telling many things. First, the data size is very large, that is why it is called big data. Moreover, it is complex data set is there, that means data set is very complex. It need not be numbers, it can be in the form of pictures. So, it is characterized by high volume, that means number of the data, then velocity, that means speed with which data is coming, say through sensors it may be coming every microsecond, and variety, that means data may be in the form of that number, it may be in the form of pictures, but it exceeds the capabilities of traditional data processing tools. It requires advanced method for storage, analysis and visualization to generate meaningful insights. So, we pictorially show that what is there in big data. So, these are the 5 V's that big data has got large volume, huge amount of data, then huge velocity, speed of data is very high, variety, lot of different type of data is there, veracity which tells reliability of the data, accuracy of the data, and value, that means big data has got some value, that means it is useful, okay, it can be useful for making some inference, that is called value, because means some data may be there which is useless, okay, that is not very important data, but in big data the data has value also. Now, I am telling you some interesting facts just to give you idea that what do we mean by big. So, it is like suppose everybody is using WhatsApp. Now, in WhatsApp about 100 billion messages are sent every single day, 100 billion, okay, that means 100 into 10 to the power 9, that is more than 1 million messages per second. 1 million is about 10 lakh, that means 10 lakh messages per second you send by WhatsApp. YouTube, every minute users upload 500 plus hours of video, that is more than 30,000 hours every hour, that means in every hour 30,000 hours video is uploaded. Google processes over 8.5 billion searches per day, 8.5 into 10 to the power 9 searches are done per day, that is about 100,000, that means it is 1 lakh searches every second. Instagram users share over 1,000 photos per second in Instagram. Amazon handles hundreds of millions of transactions daily using big data to recommend what you will probably buy next. So it takes data depending on the customer's need, they make the inference. About the growth of data, we are getting a lot of data now because of the everything is computerized. So it is said that by 2025, the world is expected to generate over 180 zettabytes of data. 1 zettabyte is 10 to the power 21 bytes. You know the byte is a unit of data that is 8 binary digits, 1 or 0. So if I write 111 8 times, it becomes 1 byte, or it can be 100 like that. That's enough data to fill 23 trillion DVDs or stack DVDs from the earth to the moon about 100 times. About 90% of the world's data was created in just the last 2 years. That means data is increasing day by day. So just to tell about the numbers, okay, I have put this slide that what do we mean by million. It is 10 to the power 6, billion is 10 to the power 9, trillion is 10 to the power 12. We say India has to make 5 trillion economy, so 10 to the power 12. Quadrillion is 10 to the power 15, quintillion is 10 to the power 18. So like that we have, and here you have byte consisting of 8 bits. Then kilobyte means 1000 bytes, or in binary it is called 1024 byte. Megabyte, then after that gigabyte 10 to the power 9, terabyte 10 to the power 12, petabyte 10 to the power 15, exabyte 10 to the power 18, okay, and then zettabyte as we said 10 to the power 21, then yottabyte, then after that brontobyte. So all these type of numbers are there. Now what is the need for big data in manufacturing, in machining, etc.? So following are the goals of any manufacturer, that he wants higher machine efficiency, lower cost, higher quality of the product. The main aim of using big data in modern day industries is to ensure a cost efficient running without compromising the safety. The key performance indicators KPIs such as cutting force, cutting tool temperature, surface quality can be directly analyzed using past data as well as real time data based on the controllable and uncontrollable variables. So that is one advantage. You can use the past data, you can use the data which is coming through sensors online, and you can make prediction. Proper implementation of the big data in manufacturing can drastically reduce the product development time and other costs associated with it. So what are the objectives actually? Accurately applying the machine learning techniques for prediction or classification. That big data is usually handled by machine learning techniques, which we will tell in the next lecture, and draw relationship among the independent variables to gain knowledge for further analysis. Various sources used for capturing of machining data or any manufacturing data include the following. One, raw data can be collected from various instruments directly attached to the machine tools like dynamometer, current sensors, camera sensors. The amount of cutting tool issued and other consumables can be collected from the store of an industry. The handwritten documents maintained by the machine tool operator also can be used. So there can be variety of data. Some can be directly from machine, some can be handwritten by the operator, and some can be obtained from stores. Now what are the challenges of big data? The data generated by manufacturing industries are of lower volume when compared to Google or Cisco, etc. So therefore many people call that as industrial big data. From in industry point of view, even if you have less data, that is called big data. And there is a high dimensionality because there are many factors. So there are challenges that there can be noise, there can be spurious correlation. That means there may not be relation between two objects, but it appears that there is a relation, and incidental homogeneity. That means there may look some similarity type of thing. Then naturally the computational cost is also very high, and there is a bias also. Apart from these challenges, reliability of the outcome of the data analysis and security of the machining database from malicious attack are cause of concern. People do cyber attack, and recognizing the outliers so as to consider the most important data for decision making. That means outliers have to be removed. So, in data driven manufacturing, we have to utilize and general rules for knowledge discovery in databases is that we have to get knowledge about manufacturing, then collection of raw data, then data cleaning is done, outliers are removed, pre-processing and transformation, then data integration, selection of appropriate functions of data mining, choosing the relevant algorithm to supply data mining, then inference and visualization, then deployment of the obtained inference, and knowledge storage, reuse and integration into the manufacturing system. In recent times, the focus has been more on the reliability and accuracy of the results obtained. So, techniques for process predictions are time series prediction model, factor based prediction model, method for prediction interval construction and long term prediction interval. Many methods can be used. Now, in manufacturing, lot of work has been done. One can see the many journal papers through Scholar Google site or Scopus site. There have been lot of publications. I am just giving some broad headings that in which areas that data-based modeling had been used. One is the quality prediction of steel, other is the condition monitoring based maintenance of smart system, then power consumption in turning using a data driven neural network. Depending on the parameters etc., you predict that how much will be the power of that this one, and then data driven finite element method for cutting force estimation during turning operation, then prediction of the rate of drilling in oil wells in petroleum sector using random forest technique. Random forest is a machine learning technique. So, these type of works have already been done, and lot of work is basically done in the manufacturing area on data based modeling. So, what are the basically inferences from the literature survey? The focus of most of the researchers has been to show the capability in different sectors of engineering people have used, and the question of cost effectiveness arises for the implementation in modern day industries. So, we use about cost conscious, about the cost thing. There are very less number of papers in framework development which utilizes the data from cloud in order to be implemented in real life situation. That means there are some papers, but many times there is a lot of theoretical discussion, but the actual application has not been properly demonstrated. In addition to that, there are numerous uncertain conditions arising in modern day industries which needs immediate attention of the researchers for data driven manufacturing. That means there are uncertain data, those type of things also should be taken into account. There are very few papers which provide answers to the following question. That means, is it justifiable to shift to data driven manufacturing when mechanistic models can still produce effective results? That means, mechanistic models are based on some mechanics laws and also based on some experiments. So, we have mechanistic models which combine the mechanics approach with empirical knowledge. Those type of things also there. So, if you go to data driven manufacturing, naturally data driven manufacturing should give better results, then only it is justifiable to use that. What is the correct procedure of accommodating uncertainties such as tool wear chatter and forced vibrations in data driven predictions? So, you have to understand uncertainties also, this also is there. Now, what is that for big data applications, many people use some open source software etc. So, Hadoop has been used for working with the data driven thing. Hadoop is an open source distributed computing framework designed for storing and processing large data sets. So, it is available on the cloud. You can use Hadoop, and it is built on the principle of MapReduce, allowing parallel processing across a cluster of computers. Hadoop is used in various industries for tasks like data warehousing, log processing and research. So, we can store big data, these type of systems. So, Hadoop comprises Hadoop distributed file system, HDFS. HDFS is a distributed file system that stores data across multiple machines in a cluster. So, that means data is stored in different machines. It is designed for high throughput access and fault tolerance. Then MapReduce is there. It is a programming model for processing data in parallel. Big data is there, so volume is very high, so data can be processed in parallel. It involves splitting data into small chunks, processing them in parallel, that is mapping, and then combining the results, that means reduce operation, and then it combines this one and it presents one consolidated result. Hadoop Yarn means yet another resource negotiator, is a resource management framework that provides a more flexible way to allocate resources across the cluster compared to the older MapReduce framework. So, these type of things are done. Hadoop, more details you can understand. Hadoop has also some other ecosystem. That Hive is that a data warehouse system on top of Hadoop, allowing users to query data using SQL like syntax. Pig is that a high level language for processing data in Hadoop. There is a language Pig, just like we have Python, etc. So, Pig is there, a high level language for processing data in Hadoop, offering a more declarative approach than MapReduce. Fume is a tool for moving data into Hadoop from various sources. Scoop is a tool for importing and exporting data between Hadoop and relational databases. Then Uji is a workflow scheduler for managing and coordinating Hadoop jobs. HBase is a distributed scalable NoSQL database on top of HDFS. So, this is these are the different type of this thing. What are the benefits of using Hadoop? Scalability. Hadoop can scale to handle massive amount of data. It is cost effective. It utilizes commodity hardware, making it more affordable than traditional data warehousing solutions. It is fault tolerant. Hadoop is designed to automatically handle node failures, ensuring data integrity and availability. It has flexibility. It can handle various data types and formats, and data locality. Computations is moved to the data, minimizing network traffic and improving processing speed. So, this is about that some exposure I have given about the big data, and now we come to the big data analytics. Okay. So, we have been using basically the statistics, but you can in some way we can say that analytics is a type of statistics, but in a very slightly evolved form. Analytics at its core is the process of examining data to discover significant patterns and extract meaningful insights. If we have got huge amount of data, but what is the use unless we make any inference out of that? So, we have to make use of analytics which will tell something meaningful, that seeing this data we can conclude this thing. So, this involves using various techniques, including mathematical methods are used in analytics. Many mathematical, we can have simple regression also, we use statistics also, and we use machine learning techniques also, which we will tell you in the next class, to sift through large data sets and uncover new knowledge that might not be immediately apparent. Otherwise, it may look huge amount of numbers and pictures, etc., but what its meaning is that we can get from big data analytics. In essence, analytics helps transform raw data into actionable information for decision making. And I have already told that in statistics you have two types of statistics. One is the descriptive statistics and other is the inferential statistics. In descriptive statistics you just describe something, that what is the average, what is the standard deviation, what is the variance, but in inferential statistics you make inferences about something like that, whether you do hypothesis testing, etc., whether this thing is superior to other thing, these type of things also you do that. It is just you know that one student, PhD student Kaustubh Chatterjee has done some work related to that using the data in manufacturing. So he has just suggested some framework, and it is something like a picture of that thing. Suppose you have got say 3 factories, there may be hundreds of factories. These various factories like factory A, B and C, if they are connected through internet, that means data from these factories can come to the internet, and then finally it can be stored somewhere, maybe on a cloud server. That means so that everybody can access it, the whole thing can be in a cloud, and then this can be stored. So these are the various issues, that how it can be this one. There is a central database repository, we can predict the performance, and then in a factory data can come from various sources. Suppose a factory is having a tool room may have different machining centers, like you are seeing that there is a one milling machine, then CNC grinding machine is there, turning center is there, CNC drilling machine is there. All that data can come and it can go to some central place where that its performance can be predicted. Then the feedback, proposed system sends feedback to this one. Suppose even the feedback can be taken, like you have collected the data, then you will predict that what is the surface roughness, but that actual surface roughness may be different. So that feedback also can go back and modifications can be done. Finally, the data can be stored in the central database repository, which can be useful for this one. So this is a type of that flow chart which has been used, made by the student, that there is a central database repository. If you give some material input and information of the parameters, then it can predict the cutting force, but this cutting force is actually measured also, and you may get a feedback, and then you can also decide various actions. So it's a very complicated type of a flow chart, but here many things are there. Is the data within range of data in the database? If it is yes, then we do one thing. If it is no, then we make only some approximate prediction, and many such questions are there. Is the real time cutting force within 95% confidence interval of the estimated one? Yes or no. So depending on that, we have to take actions. So these are the some type of actions, like estimate the cutting force with all the existing models in the database repository and choose the one which is having the least error. Reduce the model error further by updating the estimation with a suitable correction factor, and include the information in the prediction module for the new tool work combination. Then extrapolated prediction is carried out sometimes with a caveat, and the remaining incoming process parameters along with the output details are included in the corresponding modules of database repository. So extrapolated data prediction is not a very good one. When you do the prediction, you can do interpolation or extrapolation. Interpolation is somewhat accurate, extrapolation is not accurate, but sometimes we do that, but we have to understand that that information may not be that much reliable. Extract the output from prediction model from central database repository. Calculate the Euclidean and Cook's distance. We calculate that, suppose in order to understand that whether the data is close to existing data, we can use the Euclidean distance, and there is a Cook's distance also, which tells that whether the data will be influential or not. Then there are many such other actions. Okay, we go about that. Some outliers may be there which may be beyond plus minus 2 sigma limit, they have to be actually taken out. This is just a graph I have shown that there is a concept he generated, maybe more refinements can be done. Here the concept is that if you know that you have got a data, so if the similar type of data comes again and again, then its reliability increases. Say for example, when the data was only one data, I have assigned the reliability of 0.5 because it may be accurate or may not be, but if you are getting second time also the experiment gives the same thing, then reliability has increased. Then if you know third time it gives, then reliability has increased further, fourth time it is like that. So we can make a formula, he also has made a formula, but we are not giving here, but essentially that you know after some time of course the reliability saturates, even if you have 10 data or 11 data, hardly it makes difference. So these type of things can be done. And he also tried to fit regression model, but used the Cook's distance way, that a significant way to measure the influence of an observation is by using the Cook's distance. Everybody knows that how to fit a least square line, that fitting a line is okay, but I am telling something beyond that. There is Cook's distance. Cook's distance considers the residual of the output and the leverage of the point while estimating the level of influence. In other words, Cook's distance combines the value of outlier and leverage for estimating the level of influence. It can be interpreted as a means to indicate the possible locations where it would be good to have a greater number of data points that can affect the future outcomes. And leverage is basically measures how far an observation's explanatory variables are from the mean of all predictor variables. It indicates how much influence the observation has on the regression line based on its x values alone. So this is the formula for Cook's distance, ye minus yep. Yep is predicted, y is the actual, m plus 1 s square, s is standard deviation, and this is hi connecting the leverage, and this formula is there. There is no need to memorize the formula because this type of information is available in books and net, but you have to understand that Cook's distance, suppose can do that, you based on that you can take decision whether to keep that data or throw away. Like a data entry is considered to be influential only when the value of Cook's distance exceeds 1. So we can even fit a regression model and we can predict the cutting force, but we can also do the interval estimation. So that is what it is shown, that there is a interval at 95% confidence, what are the two limits, those type of things also people have to use, and this is what that has to be done. Okay. So this more details are actually available in the thesis of this PhD student, effective utilization of data for enhancing the performance of manufacturing, which is available in IIT Guwahati library. Also there are publications based on that. If you put that Kaustubh Chatterjee, US Dixit in Scholar Google, you will get many papers and you can get some idea about how the big data can be used in manufacturing, and this is what can be done. So this is about we have told about the big data and something about analytics. About statistics already we have told that very detailed discussion, so we are not repeating, but we are only telling that we can use existing resources like Hadoop, and there are many such software now which can be properly utilized. So in the next lecture we will be telling something about machine learning. So if you have got lot of data, how you can use machine learning algorithms and you can actually do some prediction or inference in machine learning also. So this will be discussed in the next lecture. So therefore let us stop the topic here itself. Okay, thank you.